So in this problem, we are provided with a set A, and we have R, which is the relation on A. It is defined as the ordered pair x comma y belonging to the relation R if and only if x plus 2y equals to 10. We need to express R and its inverse as a set of ordered pairs, and also we need to determine the domain and range of both the relation R as well as its inverse. Okay, let us begin. So here we'll start with the given set A. So here we are given the set A, which is a set containing the element x, such that x belongs to the set of natural numbers and we have x less than or equals to 10. That means we have the first 10 natural numbers. So we have set A containing the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Fine. Okay, so this is our set A. Next, what we have a relation R on A. Now, when we have a relation, we know a relation is always an ordered pair, and it is only mentioned here that it's a relation on A. That means that our R relation is defined on the Cartesian product of A and A. Fine. So, how is it defined? It is defined as the relation R is such that it is a set containing the ordered pairs x comma y such that we have x plus 2y equals to 10, and we have both x and y belonging to the set A. Okay, so this is our relation R. So using this relation, we'll try to find out the ordered pairs. Okay, so let's say we start with the first element x. So here we have an equation x plus 2y equals to 10. Now, what we'll do here, we are going to isolate y. So y is going to be equals to 10 minus x whole divided by 2. So when we choose x value to be equals to 1, so when x equals to 1, our corresponding y value was going to be equals to 10 minus 1, so that's 9. 9 divided by 2, so that's going to be 2. So we have 9 over 2. However, 9 over 2, that does not belong to the set A. So that means we have not a relation with 9 over 2. So this is not a relation. So we are not going to consider this. Next, we will choose x value to be equals to 2. So when we choose x equals to 2, then we are going to get y will corresponding y values. So 10 minus 2, that's 8. 8 divided by 2, so that's going to be 4. And clearly 4 belongs to the set A. So that means we have a relation 2R4. Similarly, we will not consider all the odd values. So for any odd values that we consider, we are always going to get a fractional value, and that's not the fractional values will be the value of y, which is not going to belong to the set A. Set A consists of only natural numbers. So what we will do, we'll consider only the even values for x. So when we choose x equals to 4, then in that case, we are going to get y equals to 10 minus 6. So that 10 minus 4, that will be 6. 6 divided by 2 will be 3. So we have 3 belonging to the set A. When we have x equals to 6, then in that case, y value is going to be equals to 2. 2 is going to belong to the set A. And then when we choose x to be equals to 8, then in that case, y value is going to be equals to 1, which belongs to the set A. We cannot choose x to be equals to 10, because if we choose x equals to 10, then y value will become 0. 0 is not a member of the set A. So that means we will have we have 4R3, this is a relationship that holds. We have 6R2 that holds as well, and then we have 8R1. Fine. So our relation R is going to consist of the ordered pair. So we will be considering the ordered pair 2, 4, which that means we have 2 related to 4. 2, 4, this is going to be one ordered pair. Next is going to be 4, 3, followed by 6, 2, and then finally we have 8, 1. So we have in total 4 ordered pairs, and these are going to be the elements corresponding to the relation R. Now that we have the relation R, we can easily define the inverse of the relation. All we have to do is interchange the positions of the elements in the position of the elements in each of the ordered pair. That means 2, 4 is going to become 4, 2. Then we have 4, 3, that will become 3, 4. Next we have 6, 2, that becomes 2, 6, and 8, 1 is going to correspond to 1, 8. So we have the ordered pairs for the relationship, the inverse of the relation R as well. Now we are ready to find out the domain of each of the two sets. So we'll start by finding out the domain of the relation R. So domain is simply to consider the first element of each of the ordered pairs. So we have 2, 4, 6, and 8. That means we have 2, 4, 6, 8. So those elements are going to be the domain of R. And next we will find out the range of the relation R. So the range of the relation R, this is simply going to be the second element of the ordered pair. So we have 4, 3, 2, and 1. So that means we have 4, 3, 2, 1. So these 4 elements are going to be the range of the relation R. Now we'll find out the domain of the inverse relation R. Now domain will be simply the first element of each ordered pair. So those are 4, 3, 2, 1, 1. Now 4, 3, 2, 1, 1. This is going to be the domain of the inverse relation R, and that is exactly equals to the range of the relation R. That means we can also define the range. So the range of R inverse, which corresponds to the second element of the ordered pair, a second element of each of the ordered pair of R inverse. So those are 2, 4, 6, and 8. 2, 4, 6, and 8 is also going to be the domain of R. So here we have successfully obtained the domain and range of the relation R, as well as the domain and range of the inverse of the relation R. And R inverse, we have specified their corresponding ordered pairs.